Hello everyone and welcome to Operating System course. I am Esin Aydın from the Computer Engineering Department at ITU and I'm here to guide you through this semester. This week our focus will be on how computers have evolved over time, evolution of computer systems, and also different types of computer systems. We will talk about real-time computers, the ones that respond instantly to commands, personal or desktop computers that you use every day, multiprocessor systems, and so on. First, I may mention early mechanical calculators from several centuries ago. For instance, Pascal's calculator, invented by Blaise Pascal, was one of the earliest mechanical calculators capable of addition and subtraction. Moving into the 19th century, we encounter Charles Babbage's analytical engine. It is designed as a mechanical general-purpose computer that utilized punch cards for input and output. It featured an arithmetic logic unit and also control flow, which makes it conceptually similar to our modern computers. So in the 1940s and 1950s, we had vacuum tube computers like ENIAC. This is ENIAC. It was the first ever electronic digital computer. It used vacuum tubes to do complex math problems and solve mathematical equations. In 1960s and 1970s, we see simple batch systems and multi-program batch systems. These batch systems have no time limits back then. Let's talk about something called real-time systems. Okay, so these are used when we have strict time limits for a computer to do its job. They are often used to control things like machines or sensors. For example, in a car, sensors send data to the computer and it must quickly analyze the data and make adjustment, of course, to avoid accidents. Okay, so real-time systems are used in scientific experiments, medical machines, and even in some household appliances too. They have to finish tasks within a certain time. Otherwise, that means they didn't work properly. So this is different from other systems like time sharing, okay? Where in time sharing, speed is important, but not critical. And also for batch system, there is no time limit is set. In 1971, something important happened, the invention of this tiny electronic part, which is called integrated circuits. These tiny circuits made way for something even more incredible, microprocessors. One of the first microprocessors was the Intel 4004. It came out in the same year, 1971. So personal computers era began with the invention of this little chip. Companies like Apple, Microsoft, IBM joined the scene. They created personal computers for ordinary people like you and me to use in our daily life. For example, Apple II came out in 1977 and IBM PC followed in 1981. These computers change everything, makes technology accessible to everyone, from regular folks to businesses. Personal computers are special because they are just for one person to use. Yeah, they are special because they are just for one person to use. You can connect things like keyboards, mouse, screens, and also small printers to them. They are designed to be easy to use. Plus, they can run all sorts of programs from games to business tools. Personal computers can use different operating systems like Windows, macOS, Unix, or Linux. Think of this as the computer's brain guiding how it works. Some people might use Windows while others use macOS. It depends on what they like or need. In these years, something called microprocessor systems has become really popular in the world of computers. These systems have two or more processors that talk to each other, sharing physical resources like memory and devices. They started off mainly in big servers, but now you can find them in regular computers and even in smartphones and tablets. These multiprocessor systems are great for a few reasons. Okay, so more processors mean more work can get done quickly, but actually not exactly n times more work. When lots of processors work together, there's a bit extra work to make sure everything runs smoothly. So we can say that they are great because it enables us to work faster. Okay. And also these systems can be cheaper than having lots of separate computers. They share things like storage and power, which saves money. If many programs use the same data, same information, it's more affordable to have all processors share that data rather than having many computers with their own copies. So we can say that it helps us to save money. And also, if one processor stops working, it won't stop the whole system. It won't affect the entire system. The other processors can handle the extra load. So the system only slows down a bit instead of crashing entirely. So it means it creates less risk of problems, we can say. Yeah. Now, think about how you use your computer. You probably have more than one program running at a time. So to make sure the computer's brain is always busy, we have a clever trick called multi-programming. It's like having different jobs lined up, so the brain always has something to do. It keeps the computer busy by always having something to do, either with the CPU. CPU is the brain of the computer, we can say, or with the input-output devices like your mouse or keyboard. Multi-programming ensures that your computer is always working efficiently. Okay, so there are also special groups of these computers too, like clustered systems. They are like clubs where computers talk to each other using special wires, namely buses. So you may realize how computers change over the years. First, computers got way faster and cheaper because of tiny parts called microprocessors. Okay, so then came smartphones and cloud computing. Okay, this made it easy for people to talk and work together online. And now there's exciting stuff happening in artificial intelligence and also quantum computing, making computers even smarter. So this journey started with simple calculators and led to the amazing computers we have today, connecting us in ways we never imagined.